Welcome all to Plutus IAS. Today we are going to discuss a very important topic from climatology, which is called heat budget and heat balance. Why the heat budget is important, let's discuss that, and what is the process of the heat budget. So if I talk about heat budget, it's just like the difference between how much radiation is coming, incoming solar radiation, versus how much radiation is going back in the atmosphere, which you call it as outgoing solar radiation. So when you get the difference of both of them, that is known as heat budget. Now, why heat budget is important and why we are studying it? First thing, that your Earth is neither too warm nor too cold because of the balance in the heat budget. Because there is no deficit or the surplus. Therefore, it's very important to read it out. The next thing that we have to discuss is how this process is going in the nature. So first is that the sunlight which is coming from the sun, this one, you call it as insolation. So incoming solar radiation is known as insolation, which comes in the form of short wave radiation. This is your short wave radiation. And there has been a question out of this topic twice or thrice in previous years. In 2024, there was a question, prelims. 2025, there was a question, and in 2022 also there was a question from this particular topic, which is a shortwave radiation, right? And the heat which is going back, which is reflecting back from the earth, you call it as reflected rays. This is known as terrestrial radiation. This is known as terrestrial radiation, and this terrestrial radiation is in the form of long wave radiation. This is in the form of long wave radiation. Now, one more thing which is important to understand is what is a process. This process is not that simple as it seems. There are a lot of layers added to this. Since this radiation which is coming from the sun is very low, right? Very low in sense, if I talk in terms of number, it is 1 by 2 billion. It's very, very less. But I will consider it as 100% of rays which is coming on the earth. Now, this 100% of rays are not directly reaching to the earth. These 100% of the rays are getting reflected by the upper layers of atmosphere. Let's suppose these rays are reflected back by the clouds and the ice caps, and this is because of the albedo effect. This is called the albedo effect. Albedo effect simply means that the rays are reflected back from the clouds and the ice caps because of its color and the properties, it is reflected back. So if I say 100% of rays were coming, so almost 35% of the rays would go back in the atmosphere. Now, how much insolation is left for the earth? So the insolation left for the earth is 100 minus 35, which is just 65% for the earth. Now, these 65% will again have to go through the layers of atmosphere, right? Because it is the troposphere which is layering up, then the stratosphere which is layering up. So this is a troposphere, and they have to go through these layers also. Your troposphere varies how much kilometer? It's up to 13 kilometer, and this will come through the layers. The moment it will come through the layers, what will happen? The remaining of that will again get reflected back. Okay, how much it will get reflected back? 14%. It will get reflected and absorbed. Some of the rays will get scattered, some will be radiated, some will be absorbed. Now these are the three processes which will happen here. Some will get scattered, some will get absorbed, some will get radiated back. So this is a process that would happen. Now, the remaining 51 units will be left for the Earth. The Earth will receive this 51 units. Now, out of which 51 units will then get reflected back in the form of long wave radiation, which you also called as terrestrial radiation. Now, please, this is a very important point to make. The kind of a radiation which is coming is your short wave. Again, I am repeating, it's a short wave, and the one which is reflected back is in the form of long wave. You also call it as terrestrial radiation. You also call it as terrestrial radiation. Now this radiation which is going back 51 units, again going back into the space. Now the heat which we feel in summers, etc., it's and also in the winters as well, but why I'm mentioning summers, the lands get heated up quite highly in the summers. And sometimes what happens, because of the presence of some greenhouse gases which have the ability to trap the heat, for example your CO2, your CH4, they are very potent gas for trapping the heat, and that keeps the earth's surface quite warm. That's why we talk about getting rid of all the greenhouse gases and their effects, and try to read out this topic and try to do its relevant PYQs. Thank you so much.